He has done MTech and PhD from ARI New Delhi, and he has qualified as ARS exam and worked as scientist for some time. Later, he joined SQUAST as assistant professor in the year 2018. He has published various articles in reputed journals. He has published three books and four manuals. He is working on horticulture mechanization, ergonomics, precision agriculture, resource management, and smart farming. Sir, please continue.
Thank you, ma'am. Thank you very much. I hope I'm audible.
Yeah, sir.
Okay. A very warm welcome to all the participants in this 21 days workshop on recent advances in agriculture, engineering, and technology for doubling farmers' income. And I would like to thank the organizers of this training program, particularly the Department of Farm Engineering, BHU Varanasi, and National Agriculture Development Cooperative Limited, Baramulla. And they provided me this opportunity to deliberate on this issue of site-specific management for precision agriculture. Internal combustion engine. For example, your steam engine. Then we started using crawler tractors, pesticides, diesel engines. We started rural electrification in 1935. And if you will see the last phase of 19th century, we started moving towards the automation and the use of electronics. And this smart farming concept initiated in 2017. And everybody is aware of the fact how fast it is progressing. So when I am saying precision agriculture, I mean we are having a conventional system whereby we used to treat the entire field uniformly. We used to consider that whole field is same. But then we realized that there are certain sections in the field which is having the variability. That means they are having the higher moisture content, higher nutrient composition. So came the concept of precision agriculture. But right now we are focused on phytotechnology, or what you call as site-specific management. That means we are addressing the variability at the pinpoint level. In this picture, you can see we are addressing a point level variability. So what is preciseness in a precision? So we are actually trying to improve the accuracy in the application of the resources. So it is a combination of many R's, like the kind of the input you are using. If I'm talking about fertilizer, so what kind of amount, how much amount you are applying in the field, at what place you are applying. There should be the right timing. It should be applied in a right method, in a right manner. And you should be using the appropriate machinery for that.
Hello, Dr. Muzammil. I think Sir has lost his connection. Let me try to call him.
Hello, am I audible now?
Yes, so you are audible. Please show your presentation again.
Sorry, there was some problem with the connection. Okay, so I was talking about the cycle of precision agriculture. So the initially we are collecting the data from the field. So that data we are using in different decision support system in order to interpret the results, and we are using those results in our application system. That is usually the variable rate system in order to vary the requirement in the field. So first phase is data collection, how it is being done. The most common method is soil sampling. The sampling, there are different methods of sampling. You might have heard about random sampling. So when you are having a very large field of more than 30 hectares, we go for random sampling. But the most common method for precision agriculture is grid sampling. So why sampling is being carried? Because we want to ascertain the field variability. So earlier we were using soil sampling understanding the soil nutrient status and the moisture composition of the field. So the kind of the technology you are using, for what purpose you are using, and what are the economic constraints that actually defines the efficiency of your soil sampling. And one thing we have to remember that this soil sampling method is very costly, and the results must be compensated with the results of the crop yield. That means a precision agriculture system should be higher yield than a conventional system. So this is the sampling procedure. So in grid sampling, what we are doing, we are dividing the fields into small grids. Then we are collecting the samples by means of random method. This way, we are actually accessing the variability in the system. But there is another method that is called the targeted or zone sampling, in which we are dividing the field in different blocks, zones, or strips. As you can see in the picture, then you can automatically analyze that which part of the field is having higher moisture, higher nutrient composition, or other factors. So this is the grid sampling I was talking about. In grid sampling, there are two types. One is grid point sampling, one is grid cell sampling. This grid point sampling means you are assessing the variability at the point level. So you can see there is horizontal lines and vertical lines. Wherever they are intersecting, you are collecting the sample from that point. But in grid cell sampling, you are dividing the field into square boxes. Then this one square box becomes your cell, and you are collecting the samples from that cell. But grid points
Hello,
takes only 2
hello.
to 3 meter into consideration, whereas grid cell is 60 to 100 meter. That means more accurate. Okay, then you are preparing different maps for the precision agriculture. Fine. So these maps are either prepared in the form of soil samples or by using the sensors. So this is the map based approach. So what we are doing, we are going in the field, we are collecting the samples, then we are taking those samples at the lab level. So once we are getting the results, we are preparing a map, for example, map of nutrient composition or map of soil moisture. Then we are using different algorithms to prepare a prescription map. That prescription map is then fed to the variable rate applicator in order to vary the requirement in the field. Another method, usually we are shifting towards automation because manual methods are having lots of errors. So in this method, we are developing a robotic system in order to collect the sample from the field. Then we are taking those samples for the lab analysis. In this method, there is less contamination. So that's why we are shifting towards robotic system. So this is the concept between map-based and real-based system. In map-based, you are getting the data from the satellites, which are usually polar satellites. Then you are using the data in your computer. You are preparing a map. Then you are feeding that map to your variable rate system. But in real-time method, you are using real-time sensors. Then sensors are getting the data. They are feeding it to the computer. Your computer is connected with a variable rate system, and it automatically varies the requirement at the field level. So this is one of the system that was developed in United States. And if you can see in the picture, they have used one sensor in order to measure the soil properties. That sensor actually sends the readings to the processor. So there's a processor placed on the top of the tractor. It processes the information and it sends the signal to the controller. Your controller is directly connected to the variable rate applicator, and it controls the fertilizer requirement, your seeding requirement, and the moisture requirement. So this system was developed way back in 2018. But the important fact is that they are using on-the-go real-time sensors. On-the-go real-time sensors are those sensors that are giving you instantaneous reading. So although they are costly, but they are very effective. So if we carry out the comparative analysis between the map-based and the sensor-based approach, obviously this map-based system is very costly because you have to collect the sample, then you have to go for lab analysis, you have to prepare the map, you have to feed that map to the variable rate system. In sensor-based method, you are using the sensor that is doing the job automatically, but those sensors are very costly. Second, the GPS system. In sensor-based system, you don't require any GPS because your sensor will automatically locate your position. Then laboratory analysis, it is not required for sensor-based system. Mapping approach, not required for sensor-based system. However, if we talk about the time, time is comparatively higher for map-based system because analysis takes a lot of time. And in sensor-based system, time requirement is less. Probably this is the reason why we are shifting towards smart agriculture. Although it is costly, but time requirement is very less, labor requirement is very less. Now, if you talk about limitations, there are certain limitations. So in terms of cost, these on-the-go real-time sensors are very costly. If you will see the operation is difficult for both, and you require the skilled manpower. Then sampling unit is 2 to 3 acres for map-based, and in sensor-based, you can locate the variation at the individual point. And if you will see the relevance, till now, India and many other developing nations, they are relying on this map-based system. And if you will see the developed nations, they are shifting towards the sensor-based system. So next is our global navigation satellite system. It is used in combination with other systems that are used for smart agriculture. So there are basically three components. One is space segment, the satellites that you are visualizing in the sky. Then there's a control segment, which called as mother station, that is used for monitoring and maintenance of the satellites. And one, the receiver, which we are having in our hands. So that is the user segment. All the three factors work together, and they are used to locate your position on the surface of Earth. So these GPS satellites, they actually give you information in two L-band radio frequencies. One is L1 and one is L2. In this picture, if you can see, I have tried to put a picture whereby you can see that your agriculture machinery is connected with the satellites, and that satellite is connected with your base station. So the point is, why we need GPS in agriculture? Because we want to locate the position of the tractor in the field, because we want to carry out cluster duster targeting, because we want to track our livestock, we want to carry out yield monitoring at the field level. Also, we want to carry out soil sampling. So this GPS is entirely based on your satellites. So minimum you require 4 satellites in order to locate the position on the surface. And the time lag, that is the time that is the time lag. Time lag is the time that is required for sending the signals from mother station to satellite and satellite to mother station. That time lag is actually used for the calculation of your position. There is one more thing, that is field sprouting. Nowadays, researchers, they are moving through the field in order to take the observation, because nowadays there's a concept of georeferenced data. Georeferenced data means you are attaching a data at a particular location. For example, you are working in a field, you want to know the nutrient composition at that point, so you can attach that data to that particular point, so that any other person will click on that point and he will get the required reading. So this location data is very essential for identifying the pest attack, soil temperature, as well as the moisture. So if you will get is actually a computer-based management system which is used for computation, storage, analysis, and display of the spatial data. You might have seen that in smart farming, we are using the data in layers form. Those layers are created by this geographical information system. Then once you will get the data, you will prepare the map. You are using the variable rate technology. So this variable rate technology is a method of controlling the variability in the field. That means at certain areas you require 50 kg per hectare of fertilizer. At certain places you require only 40 kg per hectare. Then accordingly it will adjust accordingly. Then it is either map based or sensor based, as I was explaining. So this VRT system, it includes a computer controller, GPS receiver, and GIS map database. One thing we have to keep in mind, that this variable rate technology will only regulate the application rate. It will not change your soil type. It will not change your weather, climate, and the topography. So there is another concept that is called a remote sensing. In smart agriculture, we are getting the field data using the smart sensors, and one is we are not using any contact. We are using the satellites. We are using the solar energy for getting the information. So this is one such example whereby you can see the solar energy. We are using the solar energy to irradiate your plant. The plant reflects the energy. That reflected energy is being trapped by your satellite system. The satellite sends the information to your mother station. That mother station processes the data, prepares those prescription maps. That prescription map is fed to the tractor variable rate application system, and your fertilizer rate, seed rate, moisture rate is being regulated. So this is a compact system which we are using nowadays. So if you see the types of remote sensing and the sensor is of two types. First one is the active remote sensing, where uh, you are using the source of light. You are not radar, radio detection and ranging. So it is using its own source of light to illuminate the target. That target is your plant. The plant reflects the energy and sends it to the satellite, which I was explaining. Second one is the passive remote sensing. Passive remote sensing means you are relying entirely on solar energy to illuminate the target. And these remote sensors, you are not using in your hand. You are placing at the ground level, or you are placing at the aerial level. You might have heard about UAV, that is unmanned aerial vehicles, or drones. And second one is the satellite. So you are using those sensors on different platforms in order to get that information. So in our field of agriculture engineering, we are using different sensors for the measurement of the draft force of our agriculture machinery. We are using different transducers. Nowadays, we are measuring the soil strength by means of penetrometer, and we are using different types of load cells as well. So in remote sensing, there's a concept of a spatial resolution, spectral resolution, radiometric and temporal resolution. So whenever you are getting a picture, you might be aware that picture is composed of many pixels. Fine. So that pixel size actually represents your spatial resolution. Second one is spectral resolution. So you are using different spectral bands. You might have heard we are using hyperspectral remote sensing. So you are using different spectral bands in that. Then radiometric resolution. That is the number of data levels in that particular band. Then temporal resolution. Your satellite, as I said, there are polar satellites. These polar satellites have an advantage. That is, they will visit a particular place after every 24 hours. So you are getting the information about a particular place after a required time period. So as I was saying about the sensors, these sensors are mounted on aircraft or UAV, that is unmanned aerial vehicle, your drones, or the satellite-based system. So if you will see the airborne platform, there are fixed wing platform, propeller type, gyroplan type, helicopter type, and if you will see the range, you see 45,000 feet from the surface of Earth. You just imagine the distance they are covering. They are giving you the accurate data. Then UAV platform. Right now, we are using different types of drone systems, which may be fixed wing type, electric type, or quadrocopter type. So different types of drones are being used, and we are installing the cameras on their front surface in order to capture the data of the field. Then there are satellite-based systems. Although there are a number of satellites, even India has launched certain satellites that are used for capturing the information at the field level, and their accuracy is, almost equivalent to the field-based sensors. So if we will compare all the three systems, the observation area is of drone is very low. So that's why we are using drones at a much higher pace. Right now, drones are being used for almost everything. You might have heard about spraying, seeding. Ground coverage area, if you will see for airborne system, it is 1 kilometer. For your drone, it is only 100 meters. Field of view, it is quite wide for airborne system and drones, and it is very narrow for satellite-based system. See the spatial resolution. You can reach now up to 5 to 10 centimeter. Now imagine the kind of information you are getting. You will get radiation and 8% of the visible radiation. So if you will the formula of NDVI, you are getting almost 0. You will use it for yellow based plant. You are getting a value of 0.14. That means there is a variability.
Uh, Hello. I think Sahil has again lost his connectivity. We are very sorry. Kindly bear with us. I'm trying to connect with Sir. Sir will try to join within 5 minutes. Kindly be with us.
With my internet connection. Really sorry.
So please continue.
Okay. I hope it is visible to everyone.
Yes, sir.
Okay.
Yes,
I was
yes.
talking about, sorry. So I was talking about the yield sensor. We are attaching the yield sensor to a combine harvester, and then we can get the yield maps with different set of patterns. Like you can see red color, yellow color, and the blue color. Red color shows the low yield, and the blue color shows a higher yield. Not only the yield content, you can also measure the grain protein and the oil content. And this is based on near infrared spectroscopy. If you will see the green areas and the red areas, your red areas actually shows you that your crop is having the low grain protein content, while as the blue section shows that crop is having the higher grain protein content. That means you are getting all the details from one picture. So, some of you might be thinking that, if we will compare the two, that means getting an image from the satellite and then attaching a sensor to a combine harvester. So, will there be any difference? So, this is the difference. The left side picture shows that we obtained an image. Then, on the base of that, we check the variability. Second one is we attach the yield monitor, and this is the variability. You will see there is very less difference. There is not much of a difference. So that means you are getting, this is a kind of theoretical and the practical aspect. Left side one is your theoretical because you are getting the information, then you are processing the data. Right hand side, you are getting all the information from the field level. So if you will see the financial implication, precision agriculture, no doubt we are using the sensors, we are using the sophisticated machinery, and it is comparatively costlier than the conventional system. But if you will see the lower one, the total cost, this is a per acre cost. It is almost 49,600. And if you will see the precision agriculture, it is 76,000. Fine, precision agriculture is costlier than the conventional system. But see the difference in the yield level. Your yield is only 30 ton per hectare in case of conventional system, but it is almost 135. It is almost 5 times higher than the conventional system. This is what I was talking about. So if you have to make the precision farming profitable, even though unit cost of operation is higher for that, but its production or productivity should be 5 to 10 times higher than the conventional system. Only then this system is sustainable. So, but for every technology there are still limitations. For example, there's a very high cost of sensors and the site-specific data, and there's a complexity of the tool. That means we have to upgrade the skill of our workforce. Then we have to change the culture, attitude, and perception of the farmers, including a lack of awareness of agro-environmental problems. Our farms are very small, so we have to make a compact system that will be suitable for our systems. Then there are lack of success stories. Although a number of farmers have adopted smart farming, but the success stories have not emerged as such. And particularly, we have focused on the yields. And there is a limited ability to integrate information from diverse sources with varying resolution and intensities. If you talk about practical application, last day I was searching about practical application of all those things. I came across one study where they have used a drone based system and sensors, and they have integrated those sensors by means of internet of things, and they have tried to map the system by means of ndvi mapping. That is, they have measured this normalized difference vegetative index in order to map the system. And then they have also developed a web portal and a mobile app whereby you are getting all the information on real time basis. That means you are sitting in your room and you are getting the information about the moisture concentration, nutrient level at the field level. Then accordingly you are pressing a button and you are applying the moisture and the nutrient level in order to check the variability. So this is something unimaginable. So this is what is called as smart farming. Or in another study, they have used on-the-go real-time sensors in order to measure the soil properties like pH, electrical conductivity. You can see this system where they have used an RTK level global navigation satellite system receiver. They have used a sensor for mapping the field, and they have used a tractor to operate it. So this is the field map they have obtained. So if you will see the conventional system, you will, most probably be able to collect 100 samples, 200 samples. But if you will use on-the-go sensors, you can collect thousands of samples because manual intervention is less and efficiency is higher. So, more or less, even though it might take us some time to shift towards precision agriculture, but future is smart farming and precision agriculture. So if you talk about the success stories, the cereals in North America and North Europe, Australia, that is one of the success story of precision agriculture. Earlier, they were getting a yield of almost 2 to 3 tons per hectare, but with the use of precision agriculture techniques and smart farming techniques, yield monitoring, they have increased it to almost 7 to 8 tons per hectare. Second is tea in Tanzania and Sri Lanka. So nowadays they are using yield maps like prescription maps, and they are recording the weight of each area. Then accordingly they are varying their inputs and ensuring that there's a sustainability in the tea production process. One more story is of Japan and Korea. We all are aware that Japan is very much advanced in paddy production, particularly in terms of mechanization, and they have started using highly sophisticated technologies. And to be very frank, they have almost automated the entire paddy production system, and they have reduced their footprint and ensured the environmental protection as well. So next is dates in Iran and Saudi Arabia. So they have also started using the yield maps in order to record the amount and the quality of the dates from each tree, and accordingly they are taking the decisions. So this is all about site-specific management. One thing is for sure that whatever the time it will take, but we are going towards smart farming for sure. With this, thank you very much. I will be very happy if I will get some questions from the participants.
Thank you, sir. Is there any query or question from any participant?
Ma'am, kindly unmute the participant's mic.
Okay, sir.
Participants, now you are able to unmute your mic. So Dr. Muzammil sir is here, and really he present a very nice talk, very informative. So please take benefit of his knowledge and ask questions, whatever you think in your mind, and what problems you are facing in your practical life if you are working in the agriculture and other places. So if okay, so if there is no query,
So, sir, I would like to add. All
yeah,
participants. Recently, we were facing issues of soil fertility of our fields. So, what we are working on, we have developed a NPK sensor. We have attached it with a robotic system, and we have also developed one smartphone app. That means now you can control the movement of that robot. That will go to your field, and it will give you the reading of NPK. So why I'm giving this example, there might be hundreds of problems in your field. So, and there are different types of sensors as well available. So you need to understand what are the sensors available, how to integrate them, and how to use them at the field level. And probably you will come up with many innovative solutions.
definitely, sir. Actually, this is the real problem of our
Yes.
farmers.
Yes.
When we suggest, or any agricultural scientist suggest to our farmers, kindly go to soil testing, then they are not able to prepare the collect the sample in a scientific
True.
manner. So what
True.
they are doing, they are collecting just soil from their fields and giving